Alrighty, what's up guys? Next video today on May the 4th. May the 4th be with you. We're learning about volumes of prisms and cylinders. So last time I met with you virtually on YouTube, we went over surface area of volumes and cylinders. Now the next logical thing would be to do volume of prisms and cylinders. So volume is basically just the capacity that a shape has. Meaning, what I mean by this is, if I have a box and I fill it up with water, the amount of water that I fill it up with is the volume of this, and it's measured in cubic units. So let's see what I got. So when we're doing volumes, for first off, we're going to start easy with rectangular prisms. They are the easiest. You can think of an example of a rectangular prism as just a cube or a cereal box or something like that. And to find the volume of a rectangular prism is simply multiplying the length times the width times the height. Okay? Multiplying three things because it's in 3 dimensions. So we're going to learn our first example. Let's find the volume of this rectangular prism. We have our length, our width, and our height. So volume is just equal to 9 times 17 times 24. Put that in your handy dandy calculator and you get the volume of this rectangular prism is equal to 3,672 centimeters cubed. And that's the simplicity of volume of rectangular prisms. The next two are very, very similar, just different numbers, which means that I can leave those to you to do. Next, let's generalize this volume to all other prisms. Okay, this gets a little bit trickier, but not much. Kind of similar to what we did for surface area, but now we want to find the volume. So what we need to do is we need to take the area of the base, which would be our capital B, and multiply it by the height of the prism, which is just the distance between the two bases. Okay, and our formula is just the capital B times the height. So first example. Find the volume of each prism below. If you notice here, my bases are triangular. I know these are my bases because I know the bases of a prism are congruent and parallel. These are the only two sides that are parallel on here. So I need to find this capital B, which is the area of the base. For the area of a triangle, I know it's 1/2 times the height, which in this case, we see this dotted line right here and it intersects at a right angle. That's the height of the triangle, which is 7.3. And then the height of the prism, oh, excuse me, sorry, I need to do the base. So our triangle, I don't know what this is right here, but I actually do, since the bases are congruent. If this is 12, this has to be 12 as well. So plugging that into my calculator, I get that the base has an area of 43.8. Okay, next, I have a capital B. I need my H now, and this is just the height, the distance between the two bases. And if we go from here to here, that's the distance right there, and it's 5 feet. So now I can find my volume. It's just the base, 43.8 times the height of 5 feet, to give me a total of 219 feet cubed. Okay. This next one is pretty similar. I'll leave that for you. But right here, we're dealing with trapezoid now. Okay. If we can easily see which ones are. Remember our bases. This one, you have two pairs of sides that are parallel, but you only have one pair of sides that are congruent and parallel, which are these two right here. So let's find the area of this trapezoid. It has a trapezoidal base, so capital B is equal to 1/2 times the height of the trapezoid, which is 17.9, times the sum of the two bases. So 36 plus 14 to give me 447.5. Alright, now the distance between those two bases is 25 meters, so my area is 447.5 times 25 for a total, excuse me, that's not area, it's volume, for a total volume of 11,187.5 meters cubed. And that's the volume of that prism. So for this next one, I'm not going to work it out. It's just another triangular prism one, but I will tell you how to get through it. You've got two triangle bases, but notice that you only are given two sides. But it's also a right triangle, so you can find this side when you'll need to do that to be able to find the area of that capital B. Because you know, area of a triangle is 1/2 base times height. So once you find the base, by using Pythagorean theorem, you can then find the volume. I'll leave it to you just to keep the video a little bit shorter, but if you have any questions, like I said always, please feel free to email me. And then in this one next, we have got two trapezoid bases. And I'll leave that one to you as well. Alright, now cylinders. Remember we saw that a cylinder is just two circles basically right on top of each other and some height between them, okay? Like a can. So, of course, we were talking about a can. A can is a 3D shape, so we can find its volume as well. And it is just, the formula is a little messed up on here, but it is equal to pi r squared times height. So this is basically the area of the circle times the height of the cylinder. Okay, so let's work some examples. For this one, my radius is obviously 18. My height is 15. So I have all I need now. Volume is equal to pi times 18 squared times the height of 15. Plug all that into my calculator. So it's give you an exact answer, which is 4860 pi. That's approximately 15,268.14 inches cubed. For the next one, this is the height, but this time this is the diameter. To find the radius, you take the diameter and divide it by 2, okay? And that's how you would do that. I'll leave that one for you. Alright, applications. I will work the 2 application problems with you, then we'll be finished. Alright, it says a cylinder with a 2 centimeter diameter is drilled through the triangular prism shown on the left. Find the volume of the prism. Alright, this is sort of like finding the area of the shaded figure that we did when we did those. So, only difference is if I have this, the only difference is I'm dealing with volume rather than area now. So, if I drill through some shape, and that means I'm taking out that volume, okay? So I can find the volume of the shape left over once I drill through it, and I just can subtract that volume from the volume of the original shape, okay? So let's find the volume of this cylinder first, okay? So V sub C. I know it has a 2 centimeter diameter, means my radius will be 1 centimeter. And then if you look at the picture below to the left, it has a height of 14 centimeters. Okay, so my volume of my cylinder is just pi times 1 squared times 14, which is 14 pi. And so that getting it, my approximate answer is 43.98. That's for the volume of the cylinder. So for the triangular prism, what I want to do is I want to find the area of these triangles, okay? And I know the area of a triangle. It's just 1/2 base times height. And look at that, my base and my height are the same. So this is 1/2 times 5 times 5. So this is just 12.5 centimeters square. So the volume of the prism is just 12.5 times the height of 14 centimeters. And that gives me a volume of the triangular prism to be 175. So my total volume, or my volume without the cylinder in there, will be 175 minus 43.98 to give me, just give me a second. Sorry. And we're back in 5, 4, 3, 2, I lost my page in my notes. Alright, back. It gives me 131.02 centimeters cubed. 131.02 centimeters cubed. Alright. Last problem. A diagram of Eric's pool is shown on the left. He plans to fill his pool to a depth of 4 feet with a garden hose that has an 80 feet per hour flow rate. How many hours will it take to fill the pool? Ooh, this one is different. Oh, it sounds fun. So, break it down. Plans to fill his pool to a depth of 4 feet with a garden hose that has an 80 foot per hour, 80 foot cube per hour flow rate. So, he's trying to go about right here, right? 4 feet. So, what I want to do first, I want to find the volume of the amount of water that he wants to fill up into his pool, basically. I know he wants to fill it up to a 4 foot height, but I want to know the amount of water that will be in there first, okay? And what I'm going to do with this, I'm going to take that and I will divide whatever I get divided by this rate of 80 feet cubed per hour, and that'll give me the amount of hours. So bear with me. We'll walk through it in a second after I find the volume. So the volume we're filling up to, it is a cylinder still, right? It has a height of 4 foot. Okay, my diameter of this cylinder is 27 feet, so my radius will be 13.5. So my volume is pi times 13.5 squared times the 4 feet, which gives me 2290.22 feet cubed. All right, so what I'm going to do is I'm going to do this in terms of units, okay? I want to get height somehow. I want to get hours somehow. I have what I'm given right now is I have a value in terms of feet cubed, and then I have another value, this 80, and that's in terms of feet cubed per hour. What if I canceled those feet cubes somehow and I can be left with just an hour now? So let's set that up. So if I have 2290.22 feet cubed, and I want to, if I divide by 80 feet cubed per hour, so and that's over 1 hour. Remember when this is feet cubed over hour, so when you divide fractions, that means the hour is just going to go up to the top, and that means whatever we get will be in terms of hours, and that's what we're trying to find. So I put this into my calculator, 2290.22 divided by 80 to get a total of 28.63 hours. And that's our answer. And that's volume of these different shapes, guys. I know this last one was a little bit different. If there are any questions, please feel free to send me an email. Otherwise, have a great quarantine, guys. And please keep working on all the notes and homeworks and stuff. And again, I sent out that form for you to turn the homeworks in if you'd like to. It's not necessary, but it's a nice thing for me to see that you're doing the work, and just to check on your understanding of the work too. If you have any questions, please email me, and have a great day, guys.